Yes, class. Hello. Am I audible?
Yes, ma'am, you're audible.
Okay. All right. So let's continue with the backup classes. So today I'll be able to just take 1 hour class from next Friday. Next Friday, we'll have a class duration of more than a single hour so that you all can complete the backup quickly. 5 chapters backup are remaining. No. So in the last class of backup, we have completed with calculus, differentiation and integration basics we have completed. Now let us quickly see distance and displacement and motion in straight lines theory part at least. So that at least let us complete. If we complete with the theory part, then understanding the numericals will be easier. This is the same exact class notes only I have opened, which I had done in your batch before you all had joined. So today, as I've told you, from next Friday, I'll tell you what will be the duration, most probably more than 1 hour, at least 1.5 hours or 2 hours class we'll take to so as to complete with the syllabus as fast as possible. This for this Friday, we'll have it for 1 hour only because I have to take other classes. Now, see, the first thing that comes in case of whenever we have to talk about the term distance and displacement, this is the first basic thing that will arise is frame of reference. Please be clear with this because frame of reference is important for your motion. Whenever one thing is motion, you have to understand how the other thing is at rest. So understanding whether any object is in motion, any object is at rest is an important thing. So frame of reference means like this person is standing on ground. These are two persons who are sitting within the train. Let's say the train is moving with a velocity of x kilometer per hour. This is passenger 2, this is passenger 3, this one is passenger 1. Now, if the train is moving towards the right side with x kilometer per hour, for the person first, both these two person, it will appear what? It will appear as if both these people, this one as well as this one, it will appear that both of them will be at rest with each other, right? But when this person in the ground, when this person will see both of them, what will it appear? It will appear as if both are moving with respect to the train because the entire train is moving. But when the passenger 2 will look at the passenger 3, it will appear as if both are at rest. So what is the answer to it? Are they actually in motion or they are actually at rest? Because for person 1, 3 is in motion. For person 2, 3 is at rest. So a person can be only either at rest and motion in a single time. This is just frame of reference. If we talk with respect to ground, then the person is in motion with respect to the ground. But with respect to the train, the person is in motion. This way, with reference to something, that reference is known as frame of reference. I'll share this OneNote link with you on WhatsApp group, so no need to note down anything. If anything you find you want to note it down, you can keep on noting. Stop me if you want to note it somewhere because it will take a lot of time for you. It's better I'll send the OneNote link with you. Tareem is there on the group. Tarif is there. Jania, what about you?
Ma'am, I'm not there.
You're not there.
Ma'am, even I'm not there in the group.
Okay. Tareem is also not there. Fine. Tarif, what about you? You there?
Yes, sir. Yes, Miss Anka.
Okay. You're there. Okay. So Jani and Tareem, I'll get you added. Otherwise, if it gets delayed, no, because sometimes they delay it. So I'm just sharing my Tareem already has my number. No, Tareem, I think you have texted me also before. Jani, I'm just sharing. By chance, if you are not added on the group or this gets delayed, just remind me once. I'll share the link with you. Link of this document. So it will open in your browser. You'll just see what all things have been written. All the numericals, every question, everything will be present. Now, rest is a condition when the body's position does not change with time. Motion is a condition when the body's position change with time. But both of these are with respect to frame of reference. This means a body is at rest with respect to frame of reference. Thus, third person was at rest with respect to second person. The third person was in motion with respect to the first person who was in ground. Right? Just a second. Fine. So rest and motion both are relative terms. Now see, these are all the introductory points. See, motion in 1D is there, motion in 2D is there, motion in 3D is there. So you have the three axes. If only either of these axes changes, let's say x coordinate changes or only y coordinates, it means simply the body is moving in a straight line. You call it as motion in 1D. That is only your chapter's name, motion in a straight line. If two coordinates change, let's say x, y, y, z, z, x, so we say this is known as motion in 2D, two dimensions are changing. If all the three dimensions are changing simultaneously, we call it as motion in 3D. All right. Wherever you all are not understanding, please let me know, because these are already written notes already in the class. So for students who are attending that class, the class that time, they would have understood it, and it can happen that at a certain point that is written, you might not be able to understand. So just clear it up if you have any difficulties, though this part is not difficult. Till here it was the introductory point only. Now coming to the actual topic which I wanted to discuss with you, that was distance. See, there's a difference between the term distance and displacement. Understand this term very carefully. A body moves from A point to B point, then B point to C point like this, then C point to D point in this curved path. This complete separation was 5 meters. This entire curvilinear separation was 3 meters. Again, this sigmoid S-shaped curve was 5 meters. So if I ask you what is the total path that is covered by the particle, whatever is the total path that is covered by the particle, so you will say 5 plus 3 plus 5, right? This distance, then plus this distance, then this again last S-shaped distance. So distance is actually the total path that is covered. Distance is actually the total path that is covered. Just a second, give me a second. Fine. So see, this entire path that has been covered is known as distance. It's a scalar quantity, so no need to worry about direction. Simple use the SI unit meter, this entire path. Now the term displacement, it's a vector quantity. Displacement simply means the shortest path that is possible between the initial and final position. Now, if you look here, if you look at this particular point, A point is the initial point. See, if you look over here, this A point, this is the initial point, and this D point is the final point. So you are not concerned with right now that this entire path is the path that is covered, right? You are not concerned about it. You're just concerned about the initial and the final position. So how to see about the initial and final position? See, for the initial and final position, just join the initial position with the final position. This gives you the displacement. So I'll show you as well. Like a body moved from A to B, B to C, C to D. What will be the displacement? Displacement will just be this AD. Even this entire path is different. So same thing is here. In this example also, this AD, this becomes your displacement. AD is simply your displacement. Now, see this part, I have written it separately, so let me not write it again here. Now, C class. Distance versus time graph. Now, whenever you draw, distance always increases with. This is not the graph for displacement. Why distance will increase? Because if you cover some path, if you move, however you come back to that initial position only, let's say at this is the starting point. Let's say this is the starting point, that is A point, some point. And this is, let's say, the final point. Now, some body has covered a path. And let's say it is coming, this has covered this path like this, it has covered. but now it is coming near to this and it has stopped. Let's say it has stopped. Such an abrupt random path it has covered. But see, with the passage of time, though it has reached near the point of origin, see, can you notice the distance is increasing? So distance will always increase with time. That is one of the conditions you can say, or you can say one of the properties of it. It increases with time. It can never be negative. But see, if you look at displacement, no, displacement can be zero also. If the body's initial and final position is same, let's say the body started from here, and then came back to this initial point. So what is the initial point? Initial point is this. And what is the final point? Final point is also this. So if initial point is this, final point is this, what you can conclude? You can conclude the fact that no displacement has occurred, because displacement is the shortest path between initial and final position. So this point that has been covered, this is simply initial and final position only. Displacement can be zero, right? Displacement can be positive, and displacement can be negative. This can also be negative. Why negative? Because of sign convention. Signs are considered whenever, because of direction of displacement. Displacement is a vector quantity, and vector quantities can be negative as well. This is just the difference that arises, because they are not solved merely by just simple addition and subtraction. They are solved by proper usage of vectors. Like this question was there. I'm not explaining the question in detail, but let us just have an idea to how do we calculate or see the difference between. Fine. Now, see, a body travels from A to B. So if I talk about distance, I will see this curved path that is occurring. This curved path will be the what? Circular separation. No, that is the distance, this entire curved path. But when I'm talking about displacement, I'll just see initial and final point and I'll join it with a single straight line. No need to curve your path, change your path. Whenever you're calculating displacement, simply drop a straight line and make the path closed. So AB, this yellow line that you are having here, this shows the path that is covered by the body from A to B. And the curved path was AB, that was the distance. So this yellow part AB, this is simply displacement, and curved path AB, that is 2 pi r by 4, because circle's 1/4 part is it. So 2 pi r by 4 is simply your distance. Did you understand this difference between AB? Yes or no? Distance and displacement is clear. When do you consider displacement? When do you consider it as distance? Yes or no? Any doubts in here?
Mr. Diagram can explain again.
This one, Tari?
Yes, yes, miss.
Okay. See here. This is simply a circle. That's why I'm saying don't go into the details of this diagram, because this is actually a question. Here, what is happening? The body is just focused on this fact that the body is starting from this point A, and the body's final position is point B for the first part. Now see, the body travels from A, it covers the path like this and stops at B point. See, if you see the path of it, path will be this only, no? This will be the path of it. Exactly this path. This is the path of the body from A to B. But when this curved total path that is covered by the body, this is known as distance. But when we talk about displacement, in case of displacement, you just see initial and final point and you connect it. If this is A, this is B, I'll just connect an initial and final point, and that will provide me the displacement. So this blue encirclings that I have done, that is just showing you the distance, and just joining them with a straight line is showing you the displacement, that is AB. Now clear? The rest of the things you don't need to see. That is a part of question that you will see once you will solve the question. That's what I'm saying. No, take the notes from me. Take the notes of it, and it will become easier for you to solve. Now this will become easier for you to solve it. Right. Now clear, Tarif?
Miss, clear.
Okay. Now C. Yes. So these types of questions are there. From A to B, A to C, like these solutions are there that we discussed in the class. Any part that you'll not understand any of these questions, let me know. Because the above question was very direct. Now see the way how to solve such kinds of question. Look here. This has a much simpler diagram because I have not written things over here, so you'll be able to understand it better. Look here. This is showing you just the path only from point O. See what is written in the question. A body travels from O to A. See here. This is O. This point is A. So from O to A in a circular plane, semicircular plane, then to B in in XZ axis, then from B to final point that is to the final point that is present. It is how it is traveling to the final point. It is traveling parallel to the y-axis. So this curved path, then this straight line, and this parallel final line. This is how the path looks like. Now you are asked to calculate the distance. You are asked to calculate the displacement. See, distance will be what? For semicircle, the perimeter is what? Pi r. 2 pi r is for a circle. So for semicircle, it will be pi r only. So for if radius is a, this part will be pi a. Then pi a plus 2a. See what all things you'll add up. Pi a plus this 2a plus this 3a. All these three's quantity getting added will give you distance. But how will you calculate displacement? This is distance you have written also here. Pi a plus 5a is equal to a pi by 5. That has been taken from. This is the displacement. Oh, sorry, that is the distance. See, displacement will be calculated. We have not discussed Cartesian form, no? Cartesian form, and this we'll discuss in vectors. Leave the second part. That we'll discuss in vectors only. Fine. So distance and displacement refer to these things only. You have to understand these 2 points. Now velocity is important, class. See. So when a certain amount of distance is covered in a certain amount of time, let's say 5 meters is covered in 3 seconds, right? In 3 seconds, 5 meters has been covered. That distance that is covered per unit time, we call that quantity as speed. And when it is displacement divided by time, we call that quantity as velocity. So speed is equal to distance by time, and velocity is equal to displacement by time. From the difference between distance and displacement, we can, whatever is the value given for distance and displacement, we can get the values of velocity. So distance will determine the value of speed, and displacement will determine the value of velocity. So this rate of change of distance is known as speed. Whatever is the change in amount of distance, that is covered per unit time. Whatever is it, like let's say 5 meters per 3 seconds or 5 meters per second. So you can say 5 meter covered in 5 seconds. That is 1 meter per second becomes the velocity. So either you write it directly as it, or you just make it the use of formula, because both have the same meaning, rate of change of distance. So rate of change of distance, rate of change of displacement. Both the things, all the things have been written here. Now see, rate of change of distance, apart from this, then scalar. Then this is a scalar quantity. Scalar quantity is speed. If when we are talking about speed, because we are considering distance, so it will be a scalar quantity. If it is displacement, that is velocity, that becomes a vector quantity. Why are we studying scalar and vector? It's because of this reason that scalar quantities have just the formulas, they have the magnitude, but they have the SI unit, but they do not have any direction. In case of velocities or in case of any quantity that has magnitude, that has SI unit, it can obey the vector laws. It has to obey. So those quantities are known as vectors. So the speed is this. Only one more thing. Many quantities are given in kilometer per hour. So convert it into meter per second by multiplying it by 5/18. Simply multiply it by 5/18 with this term. Now types of speed. This is important. Firstly, you have uniform, non-uniform speed. Just yes, see, now types of speed. You get two types of speed, that is uniform and non-uniform. Among non-uniform also you have average and instantaneous. Now what is meant by, let's discuss the first one, that is uniform. So in case of uniform speed, rate of change of distance is uniform. It means 5 meter per second is covered in, let's say 5 meters are covered in, let's say 2 seconds. So I'll say 5 meters are covered in first 2 seconds. Then again I'll say second 5 meter is covered in another second, like this. So when the rate is uniform, rate of change of distance, rate of change of displacement, any of these two quantities, you call it as uniform displacement. When it is non-uniform, it will not be constant. In the sense, not same amount of energy will be changing over time. For velocities, you prefer, for velocities also you can do one thing. C class, for non-uniform, no, and for uniform, best way to remember is uniform, same amount is changing. If one in, let's say 5 meter per second is the velocity initially, so throughout it will be 5 meter per second. But when we are talking about non-uniform one, in case of non-uniform one, it is changing. Now it can also be of two types, average and instantaneous. If the velocity that is changing, velocity is changing with a time duration, then you use average. If a time second is given, you use time instant. So this is an overview of velocity. Let us just start with the proper uniform speed. So uniform, I think velocity, at least you should note it down. Do one thing till this, just write down the introductory point of velocity. Rest of the things will be shared with you till here. Because no, if you do not have points till here, otherwise it becomes confusing in the end. Note down this part. So this was what I was telling you regarding uniform speed. See, in the first 2 seconds, how much distance is covered here? 5 meter. In another 2 seconds, distance is covered. This is also 5 meter. Then here also 2 seconds, 5 meter. So this is known as uniform speed. This is known as uniform velocity. Here, what is happening? One distance is changing in same span of time. So velocity at every point will be same. That is known as uniform speed. Speed or velocity, we'll see uniform speed. See speed, then velocity will become easier. And in non-uniform, see this figure. This is 2 seconds, that in 2 seconds, 5 meter is covered. In 2 seconds, 6 meters is covered. In again 3 seconds, irregularity of time, 5 meters is covered. Like this is the difference how the body covers distances in equal intervals of time and opposite to it. In unequal distances in equal interval of time or equal distances in unequal intervals of time. Then comes the concept of, yes, average speed is very important. Average speed, this is important because average speed, though, how to solve it? Basically calculate all the distances that are present and divided by time. For example, this is a question in front of you. So total distance will be 10 plus 20 and total time will be 10 plus 15. So that will be 2 meter per second. The average velocity. Fine, it will be 2 meter per second, like this. See this question. Again, now velocity is given, time is given, but distance is missing. So what did I say? Calculate all the total distance. So how can you calculate distances? Multiply velocity with time, that gives you first distance, multiply velocity with second, that gives you second velocity, and then calculate the average speed. Okay, do one thing, class. Try this numerical. Try this numerical, question 3. Then I'll explain you. All those who get the answers, share with me. See how to do this question. Did you try? Any answers? Tareem? Jania, Tarif, did you try?
Miss, I think it's a three equal parts, right? So we can like 3 into V1, 3 into V2, 3 into V3. Can you do like that?
Yes. See, somewhat like this. See, body covers its total journey in 3 equal parts. So take the entire distance as 3x and divide it by 3. So each distance will become x. And then, see, I'll tell you. Let me tell you this. See here. This is the entire distance. So I have taken total distance as 3x. You can take the total distance as x also. Then each part will become x by 3, x by 3, x by 3. So I wanted to avoid that fraction. That's why I took 3x. Now when I divide 3x by 3, I get each part as x, x, x. So total distance will become 3x, but total time will be what? Time is distance by speed. Because speed is given in the question. So that will be x by v1. Time 2 will be x by v2. Time 3 will be x by v3. And so when you solve it here, x gets cancelled. So you are left with 3 v1 v2 v3 by v2 v3 plus v1 v3 plus v1 v2, like this. All right, note down the solution.
Yeah.
See, class, this was what I was trying to tell you. Average and instantaneous difference. When to use average, when to use instantaneous. See, if I say no, t is equal to 2 p.m., that's a time instant. If I say t is equal to 6 p.m., that is again a time instant. But if I say t is equal to from 2 p.m. to 6 p.m., so from 2 p.m. to 6 p.m., it means 6 minus 2, 4 hours. So that is a complete duration. 4 hours are taken. Initial time, final time, and this is a complete time that is taken. So this is a difference between instant and duration. Instant means exactly at t is equal to 0.03 seconds. T, or you can say instant time means 0.001 second, 0.03 second. Like this, you have a particular time instant. But for durations are have a beginning and have an ending. You say from Monday to Tuesday, from 2 p.m. to 6 p.m., from 3 second to 4 second, that's a duration. So instant is usually used whenever a particular moment of time is given, and speed that is calculated, it is known as instantaneous speed. So in instantaneous speed, you basically see, this is just the difference that you have to remember. Average velocity is displacement that is covered by average speed is distance that is covered by time that is taken, time interval. But whenever you calculate instantaneous velocity, wherever you calculate, see, in case of instantaneous velocity, here I'll differentiate this. So this will be dx over dt. In case of average speed, you take the difference between, or take the change in distance by change in time. In instantaneous, you differentiate distance with time. Understood? Whenever, how to identify, let me show you a question, how to identify it. Like this question says equation of position is given. Calculate speed at t is equal to 2 seconds. And second 2 seconds means instant or duration, class?
Ma'am, instant.
Instant. So you will differentiate this. For time instant, you will differentiate this. Proper t square differentiation will give you 2t. Now put the value of t. Like these are some other questions. These you can see. These you will be able to understand when you see the solution. Now, velocity is exactly the same thing, just a vector form. Same thing. But here one more component will come is the direction. In case of speed, we were continuously talking about only the magnitude. There was no mention of direction. No mention of direction. But now for velocity, you have direction. This is the difference. See, you will be able to understand this better. Velocity is the rate of change of displacement. Types will be uniform, non-uniform. So uniform, equal displacement covered in equal interval of time. Non-uniform, unequal displacement covered in unequal interval of time, or equal displacement covered in unequal interval of time. So this is exactly similar to what you've studied for velocity, but still there's a difference. This minute difference is there because of direction. So it can happen only magnitude is changing, direction is not changing. Then also we'll say the uniform velocity has changed. If both the magnitude and direction same, then also we can say this instantaneous non-uniform velocity has changed, or velocity is non-uniform. Like this. Again, same thing. For instant, particular time instant, you have instantaneous velocity. For average interval of time, you have average velocity. This is how you calculate it. See, I was referring to here. You integrate this to get distance, but for velocity, you differentiate it. For velocity, you differentiate only. So this is differentiation of displacement with respect to time for instantaneous velocity. This is exactly the same. Do one thing. Okay, you can note it later on only. From this, no. But at least try this, could try at least one single question from your side, so that it will become easier for me to know whether you have understood anything or not. This is a question you'll be able to see through the solution. Class, find out this. X is equal to 3t square plus 2t minus 1. Find out velocity at t is equal to 1. Second, this example. Send me your solution in the chat column. Yes, class, any answers? 2 minutes have passed. Last 1 more minute. Not 7. See, 1, I think you have not taken. See, differentiation. Okay. 8 only, no? Yes, right. See, this differentiation is 3t square. 3 into t square. So that becomes 60. And here from 2t, you have 2 only. And 1 is a constant. I hope others are well with differentiation and integration, because I have already taken a class where we had discussed calculus, mathematical physics. So this will come out to be 8 meter per second. Lastly, everything similar to this is acceleration. Same things, class, same things to have for in case of acceleration also. The way rate of change of distance was speed, rate of change of displacement was velocity, same thing. Now rate of change of velocity is known as acceleration, and not change rate of change of speed. It is always rate of change of velocity, because acceleration is a vector quantity. So it is rate of change of velocity, or you can say change in velocity with respect to time. Now types of accelerations are there. They have exact the same basis: uniform, non-uniform, average, and instantaneous. See, class, this pattern has not been changed till right now. Uniform velocity means uniform acceleration means the velocity, same amount of velocity is changing with certain interval of time. Whereas for non-uniform, random intervals are changing at random intervals of time. It can also happen one is at rest, other one because of some, one is at rest as in one is decreasing, one velocity can be decreasing also, because your acceleration is a vector quantity, right? Acceleration is a vector quantity. So for acceleration, you can get negative values because it is rate of change of velocity. The same thing, if equal amount of velocity is changing in equal interval of time, that is known as uniform. If unequal is changing, then non-uniform. It can be average, it can be instantaneous. For average, you take the instant, you take the duration. This is a very basic question. See, this is what is uniform acceleration and non-uniform acceleration. See, in case of uniform acceleration, 4 meter per second for 2 seconds, 4 meter per second for 2 seconds. This will remain throughout. So you are getting acceleration as 2 meter per second square at every point. For non-uniform acceleration, this will be 3t. For non-uniform acceleration, this will be 3t. Let's assume this is 3t. So for time 1, t is equal to 0 second, acceleration is 0. For t is equal to 1 second, acceleration is 3. For t is equal to 2 second, acceleration is 6. So acceleration's value will be changing in non-uniform acceleration. This is the difference between uniform and non-uniform. Class, calculate this. A car moving with velocity 10 meter per second takes a U-turn in 5 seconds, and it continues to move with the same speed. Calculate its acceleration. Note it down and try it. C class. Car is moving first with velocity 10 meter per second, then it takes U-turn. It means now the direction of velocity is different. So here what I'm trying to tell you is one direction you take as positive, take other as negative. This is the sign convention. This will be used everywhere, sign conventions. I think in the normal classes also, regular classes that we are having, we're using this term sign convention, one positive, one negative, one positive, one negative. Especially in relative motion question, this is used a lot. So let's say I have taken the right as positive. Let's say I have assumed that I have taken the right as positive and I have taken the left as negative. You can take the right as positive, you can take the right as negative, you can take the left as positive. That is up to you. In your answer, you just have to mention what is your sign convention, and whatever answer you will get, that will be considered. So let's say I have assumed that right is positive. So in your answer sheets, do mention this point, that right hand side direction, this is taken positive. So this velocity will be 10, another velocity will become minus 10. Now see, what will be the change in velocity? 10 minus minus 10. So that will become 20, right? So 20 divided minus 10 minus 10. No, final is minus 10. Initial is 10. So minus 10 minus 10, that becomes minus 20. And what is the total time that is given? 5 meter per second. So if you divide it, you're getting minus 4 meter per second. So minus 4 meter per second is showing what? Minus 4 meter per second is showing that direction of acceleration is towards the left side. Why towards the left side? Because left side only we took it as positive. All right. Even if you calculate it using right as, if you take right as negative, then answer will be 20 by 4. That is 4 will come positive. So this will show you that this is again towards left. What I'm trying to tell you is, see, if you choose right as positive, you are getting minus 4. That is pointing towards the left. When you choose right as negative, you get 4 plus 4, which is showing again that it is towards left only. So basically, whatever you say, whatever side you choose, final answer will be given, say, by both. Same answer you will get. It's just that you have to mention by yourself. All right, you have to mention that your which direction is positive, which direction is negative. One more thing, class. In acceleration, same thing. Change in velocity by change in time for average.